You ever feel like physics is speaking a whole other language? Well, you're not wrong. In a way, it is. And its secret language is math. Today, we're going to decode 3 of the most crucial concepts you need to know. Let's jump right in. So, how does physics pull it off? How does it know exactly where a planet's going to be, or where a baseball's going to land? It's not magic, I promise. It's all about using a very specific, very powerful set of mathematical tools. And that's exactly what we're going to do. Think of it like we're opening up the ultimate physics survival kit. Inside are the 3 fundamental tools you absolutely have to have. You ready to take a look? Okay, first up in our toolkit is the absolute cornerstone for describing, well, pretty much anything that moves or gets pushed around. It's the vector. You can think of it as the built-in GPS for physics. So what is a vector, really? It's actually super simple. It just has 2 parts. First, there's magnitude, which is just the how much part, like 50 miles per hour. And second, there's direction, the which way part, like north or up or to the left. You need both for it to be a vector. This slide lays it out perfectly. On the left, you've got a scalar. That's just a number. If I say a car is going 50 miles per hour, that's its speed. It only tells you how fast. But now look at the right. The vector version is velocity. It tells you the car is going 50 miles per hour east. See the difference? It tells you how fast and where to. It's the whole story. So how do we work with these things? Well, let's say you walk 3 miles east and then you turn and walk 4 miles north. You can't just add 3 and 4 to get 7, right? That's not where you end up. Instead, you use this triangle law. You draw your first vector, then you stick the start of the second vector onto the end of the first one. The grand total, your final position, is just a straight line from where you started to where you finished. It's visual, it makes sense, and it's incredibly powerful. And here's the bottom line. Once you get the hang of vectors, you've basically unlocked the language to describe anything that pushes, pulls, or moves through space. It is the absolute foundation. All right, let's grab our next tool. Now, this next tool, it sounds like a complete paradox. I mean, how on earth can you add up an infinite number of things and somehow get a single, simple answer? Well, let's find out. Here it is. This is the formula, and it looks almost too simple, right? A is just the very first number you start with in your series, and R is the common ratio. That's the number you keep multiplying by to get the next piece of the puzzle. That's really it. But let's be honest for a second. This feels weird. I mean, it goes against everything we think we know. If you keep adding numbers on and on and on forever, shouldn't the total just get bigger and bigger until it's, infinite? How could it possibly just stop at one specific number? And the answer is 2. Here's how to think about it. Imagine you walk 1 full step, then you walk half a step, then a quarter of a step, then an eighth, and you keep doing that forever. You're always moving forward, always adding a little more distance, but the steps get tinier and tinier. The crazy thing is, no matter how long you do it, you'll get infinitely close to taking 2 full steps, but you will never, ever cross that line. Your infinite journey has a finite limit. And trust me, this is way more than just a cool brain teaser. This is a critical tool for solving really complex physics problems. And for students out there, pay attention. Concepts based on this exact idea have actually appeared on major exams like the NEET. So yeah, it's pretty important. All right, time for our final tool. This one is the physicist's secret weapon for when things get really, really messy. It's the ultimate life hack, the smart shortcut. Okay, check this out. On the left, you've got the full proper equation. It's 100% accurate, but honestly, it can be a huge pain to calculate. But now, look to the right. That's the shortcut. It's just 1 plus n times x. It's clean, it's fast, and in the world of physics, most of the time it is so close to the real answer that it might as well do perfect. But, and this is a huge but, there is one golden rule you absolutely cannot break. This shortcut only works if that little x is tiny, like really, really small compared to the number 1. We're not talking 0.5, we're talking 0.001. As long as x is small enough, this approximation is your best friend. So, where would you actually use this? Well, a perfect example is calculating the tiny change in gravity when you go from the ground floor to the top of a skyscraper. The height you've moved is incredibly small compared to the entire radius of the Earth, so that x value is tiny. This shortcut turns a super messy calculation into something clean and elegant. And there you have it. We've just opened up the Physics Survival Kit and armed ourselves with 3 incredibly powerful tools. You are officially ready to start describing the world like a physicist. So let's just do a quick recap of what's in our new toolkit. We've got the vector, our guide for anything with a size and a direction. We have the infinite sum, our secret weapon for problems that seem to go on forever. And we've got the binomial approximation, our smart shortcut for those super complex calculations. At the end of the day, it's so important to remember that these aren't just abstract formulas or tricks with letters and numbers. They are, quite literally, the essential rules we use to describe the reality all around us. It really makes you think, doesn't it? If just these 3 basic tools can help us chart the course of a planet or figure out the force of gravity, what other incredible secrets is the universe just waiting to tell us if we just keep learning its language?